This assessment asks us to show the mechanism of the reaction between water and this anhydride. It specifically points out to note whether acid or base or neither is present. We are doing this reaction not in acid and not in base, with just water present. And so what does that mean is we can't turn water into a really strong nucleophile and have hydroxide attack. We can't protonate the carbonyl and have water attack. So we just have to use water as it is. And while that will have implications for the speed of the reaction, it will only have a slight implication for how we draw the mechanism. And so what we have to do with no acid present, we're just going to have water attack directly. We could really attack either carbonyl here, but because there's an extra alkyl group over here, we'll assume that this one is a little bit more sterically hindered, so we'll show water attack that one preferentially. There's probably not enough steric hindrance to make a huge difference, but why not be consistent with this? Now, this is not going to be a particularly favorable reaction. Water's not a strong nucleophile, and for it to add and put a negative charge on that oxygen probably is not going to be super favorable, so we'll use these equilibrium arrows. When it attacks, though, it's going to bring along its proton and produce this as our tetrahedral intermediate. Now at this point, we can go ahead and show that this tetrahedral intermediate can collapse back down to kick out the good leaving group, in this case the acetate, still showing it as an equilibrium reaction, to give this molecule, which is now that positively charged oxygen, is even less stable than it was a minute ago, and this resulting carboxylate. This carboxylate can now remove that proton to generate the two molecules on screen, the two carboxylic acids that we were on our way to in terms of the hydrolysis.